We stand at the edge of a shift that may redefine what it means to be human. The metaverse is more than another technological step forward. It is a parallel reality where the line between physical life and digital existence fades a little more each day. What happens to the brain when we roam virtual worlds for hours? How does perception change when the body stays still, but the mind moves through infinite digital spaces? These questions have moved beyond science fiction. Every day, millions of people spend a large portion of their lives inside digital environments, and that number is rising rapidly. Neuroscientists are both concerned and fascinated by the brain's remarkable capacity to adjust to unfamiliar realities. We examine how immersion in the metaverse reshapes neural pathways, the dangers of psychological dependence on virtual worlds, and the challenge of preserving mental stability as consciousness undergoes digital transformation. The human brain is a powerful adaptive system, able to reorganize itself in response to new conditions. This property, called neuroplasticity, is becoming crucial in the age of the metaverse. As we enter virtual environments, the brain starts building entirely new neural networks, adjusting itself to a digital form of reality. Studies show that frequent interaction with three-dimensional virtual spaces activates the same brain regions used for navigation in the physical world. But something unexpected occurs. These regions begin to operate in new ways, forming distinct cognitive maps of virtual environments. Researchers at Stanford University discovered that people who spend several hours a week in the metaverse demonstrate measurable gains in visual spatial abilities. Their brains effectively learn to function in two realities at once. The effects are especially striking in older adults, for whom virtual reality becomes a training platform for cognitive performance. In one study, participants aged 65 and older experienced clear improvements in memory and reaction time after 3 months of regular sessions in a tailored metaverse. The brain does more than adjust to this environment. It can flourish within it, using virtual experiences to reinforce real neural circuits. The influence of the metaverse on the brain runs deeper than most people realize. At the core of this process lies an ancient reward system, a neural network shaped by evolution to drive survival and reproduction. When we reach objectives in virtual spaces, the brain releases dopamine, a chemical linked to pleasure and motivation. Designers of metaverse platforms intentionally tap into this biology by building achievement systems, digital rewards, and mechanisms for social approval. Every unlocked level, every virtual badge, every like from an online peer delivers a small dopamine surge, described by users as a reason to return again and again. Studies show that the brain does not always separate virtual success from real achievement. For neural systems, winning a digital contest activates the same pleasure centers as victory in the physical world. The difference is that virtual rewards arrive faster, require less effort, and follow more predictable patterns. This creates a serious risk of addiction. The brain starts favoring quick virtual gratification over real accomplishments that demand time and effort. Over time, tolerance builds, and longer sessions in the metaverse are needed to reach the same level of satisfaction. Neurobiologists caution that extended exposure to virtual environments can dull dopamine receptors. As a result, sensitivity to natural pleasure in everyday life may decline. Entering the metaverse is not just a technical connection to servers. It is an entry into a new social space. Avatars become our digital bodies, used to communicate, show emotion, and form bonds. But how does this shift affect social abilities? Research offers a mixed answer. On one side, the metaverse creates new possibilities for people with social anxiety. The protective layer of an avatar reduces psychological pressure, making self-expression easier and more open. Individuals who struggle with face-to-face interaction often feel more confident in virtual communities. Brain imaging shows lower activity in the amygdala, the region linked to fear and anxiety, during virtual social contact compared to real-world interactions. Yet this advantage comes with costs. Avatar-based communication removes much of our nonverbal language. Facial microexpressions, subtle posture changes, and unconscious gestures are reduced or lost. These signals are essential for building empathy and emotional awareness. Children and teenagers who mainly develop social skills in the metaverse show a weaker ability to interpret emotions during real-life interactions. Communities in the metaverse form under different rules than those in the physical world. People connect through shared interests and beliefs, not location or social rank. This leads to distinct psychological effects, including strong attachment to virtual groups and a fading line between digital and real identity. The separation between a person and their avatar can become thinner than expected. The shift of consciousness into a virtual body is not theory. It is an everyday experience for millions of users. The brain has a powerful ability to accept a digital body as its own. This process, called the illusion of embodiment, can appear within minutes of immersion. Researchers at the University of Barcelona found that controlling an avatar activates the same brain circuits used to perceive the physical body. To the brain, the virtual form becomes a genuine extension of the self. The effect intensifies with heavy use. People who spend hours each day in the metaverse begin to carry traits of their avatars into real life. Their gestures change. Their speech patterns shift. Even their sense of identity begins to evolve. One participant in the study confessed, "At times I catch myself forgetting that I can't walk through walls or teleport in real life. My virtual self does it constantly." This erosion of the line between realities can trigger dissociative states, a condition where a person feels detached from their body or sense of self. To preserve healthy boundaries, psychologists advise deliberate rituals for entering and leaving the metaverse, frequent breaks, and techniques that anchor attention in the physical world. Virtual environments do more than reshape how we see reality. They also generate specific cognitive distortions. The human brain, not designed to switch endlessly between worlds, can fall into new mental traps. One of the most common is confirmation bias. Metaverse algorithms adapt to personal preferences and build a perfectly comfortable information bubble. Users are shown only what aligns with their views, reinforcing beliefs without critical examination. Researchers at the Massachusetts Institute of Technology found that after 3 months of regular exposure to personalized virtual spaces, participants developed noticeably more rigid opinions on controversial topics. Another major distortion involves time perception. 80% of surveyed metaverse users admitted they often lose awareness of time while immersed. Neurophysiological data shows that during deep immersion, the brain enters a distinct operating mode in which its internal clock slows. 3 hours in the metaverse can feel like only 1. This helps explain why leaving virtual environments on time is so difficult. The illusion of control is especially risky. This distortion causes people to overestimate their influence over events. In the metaverse, where many outcomes truly are controllable, this illusion intensifies and can spill over into real-world behavior. So what happens to the brain during extended immersion? Recent neurophysiological studies offer troubling insights. Scientists at the University of California examined volunteers after 4-hour virtual reality sessions and observed clear shifts in brain activity. EEG readings revealed increased beta waves and reduced alpha rhythms, a pattern linked to heightened arousal and poor relaxation. Even 2 hours after exiting the metaverse, the brain remained overstimulated, making sleep onset harder and lowering sleep quality. Disruptions to circadian rhythms are especially concerning. The intense light emitted by VR devices, particularly blue wavelengths, suppresses melatonin production, the hormone that regulates sleep cycles. People who regularly enter the metaverse in the evening often experience a circadian shift of 2 to 3 hours. Other physical indicators of excessive immersion include elevated cortisol levels, faster heart rate, and increased blood pressure. One condition, known as metaholistic headache, deserves special attention. This specific discomfort appears after long VR sessions. Brain imaging shows temporary disruptions in blood flow within the occipital and temporal lobes in affected users. Addiction to the metaverse develops through the same neurobiological pathways as other behavioral addictions, but with distinct characteristics. At its core is a familiar process, repeated activation of the brain's reward system followed by dopamine receptor exhaustion. The metaverse adds another layer. It becomes more than a source of pleasure. It turns into a substitute reality. The earliest warning sign of addiction is rising tolerance. Users need increasing amounts of time in virtual environments to feel the same emotional impact. 2 hours become 4. 4 turn into 8. At the same time, withdrawal symptoms appear. Irritability, anxiety, and even physical discomfort arise when access to the metaverse is cut off. One of the most serious warning signs is continued use, despite clear negative outcomes. Sleep disturbances, declining performance at work or school, and growing conflicts with family and friends become common. Unlike social media dependence, metaverse addiction is often paired with dissociative identification. The individual starts to view the avatar as a more authentic version of themselves. For self-assessment, specialists suggest a simple exercise. Try avoiding the metaverse for 1 full week. If the idea triggers intense anxiety or feels impossible, it may be time to seek professional help. Children and teenagers are especially vulnerable to the influence of the metaverse because their brains are still developing. Unlike adults with established identities, young people are in the process of self-definition. For them, virtual spaces are not just entertainment. They are environments where identity is actively shaped. Neurobiological studies show that the prefrontal cortex, which governs decision-making and impulse control, does not fully mature until around age 25. This makes adolescents particularly sensitive to virtual stimulation and social validation within the metaverse. For many, digital popularity can outweigh real-world accomplishments. The effects on emotional regulation are especially concerning. During a critical stage of emotional development, children may adapt to the simplified emotional expressions of avatars. This can reduce their ability to recognize and process complex emotions in real interactions. Effective parenting focuses on guidance, not bans. Exploring virtual environments together and openly discussing experiences helps children build critical thinking. Digital literacy is now as essential as reading and writing. Parents should teach children to identify manipulation, safeguard personal information, and maintain healthy boundaries between virtual and physical life. Virtual worlds also offer powerful possibilities beyond entertainment. Their therapeutic potential is emerging as one of the most promising areas in modern psychology and neurorehabilitation. Virtual exposure therapy has transformed the treatment of phobias. Patients with a fear of flying can experience a realistic virtual flight while remaining in a safe clinical setting. The system gradually increases exposure, allowing the brain to adapt without overwhelming stress. The outcomes are striking. After 10 sessions, 75% of patients show a marked reduction in symptoms. The metaverse is also highly effective in treating post-traumatic stress disorder among veterans. Recreating combat scenarios in a controlled virtual space helps traumatic memories be processed and integrated. For people with disabilities, virtual environments provide freedom and opportunity for growth. Individuals with paralysis of the lower limbs who control fully mobile avatars activate mirror neurons, supporting neuroplastic changes in the motor cortex. This goes beyond psychology. Research has documented real physiological changes that accelerate the recovery of motor function. In a reality where digital and physical worlds are increasingly fused, protecting our cognitive health is no longer optional, it is essential. Digital brain hygiene refers to a set of intentional habits that help preserve mental clarity and emotional stability while engaging with the metaverse. The foundation of safe immersion is strict time control. Neurophysiologists suggest the 20-minute rule. After every 20 minutes in a virtual environment, take a 5-minute break in the physical world. This pause helps the brain reset and reduces sensory overload. Equally important are clear entry and exit rituals. These are simple actions that signal a shift between realities. Before entering the metaverse, pause and take several deep breaths. After leaving, drink a glass of water, walk barefoot on the floor, or perform light physical movement. These habits help the brain separate experiences from different worlds. Establish technological limits. Use timers that shut down access and apps that block the metaverse during set hours. Schedule digital detox days. Complete breaks from virtual environments. Begin with 1 day per week and slowly extend the duration. Such pauses allow the dopamine system to recover and lower the risk of dependence. Practice conscious presence in the real world. Focus on bodily sensations, nearby sounds, and surrounding scents. This reinforces neural pathways responsible for perceiving physical reality. Standing at the intersection of technological advancement and human nature, we must acknowledge that the metaverse is more than a new tool. It marks a new stage in human history. Exploring its neurobiological impact reveals a clear dual nature. Like fire, the metaverse can provide warmth and creation, but it can also cause harm if handled carelessly. The real question is not whether we should use it, but how to use it responsibly. A future where digital and biological worlds exist in balance demands awareness and intention. We must learn to navigate digital oceans without losing our connection to the shore of reality. Technological progress cannot be stopped, but its direction depends on our choices. Priority must be given to building ethical virtual environments that respect human neurophysiology. The metaverse of tomorrow should not be a place of escape, but a platform for expanding human capability, where technology supports self-understanding and growth. The brain will continue to adapt, but it needs space to do so naturally, without being driven by artificial overstimulation. Finding this balance is the foundation for living peacefully alongside the technologies of the future.